Talk of the day is Alex Mann, who will be talking to us about bear traps, the logging addiction.
Yeah. Hey, everybody. So first, I want to thank everybody who made it up here through the bit of a labyrinth. I think David Bowie was somewhere along the path. Rest in peace. This is going to be interesting. So that gentleman in the back there is running the slides, and my notes are up here, and they are not at all connected. So we're going to see how this goes. Yeah, so that does that, and wonderful. So my name is Alex Mann. I'm a programmer at CircleCI. I'm a recent transplant to Milwaukee, Wisconsin. I came via way of Philadelphia last. I've been coding in Clojure for about 4 years now, and I've been fighting with logging in Clojure for about 4 years now. It always seems to me that there's maybe some XML file, or maybe I've gotten the right XML file, but it's in the wrong place, or it's the right XML file, but it's being interpreted by the wrong logger. The class name is wrong. Maybe I have two jars on my class path that are canceling each other out. Maybe there's an envar that exists that I didn't set quite right. Maybe the envar is in the right format, but for the wrong logger, et cetera, et cetera, et cetera. And logging is, unsurprisingly, a pretty simple thing. This is not something that should take any of us more than maybe 10, 15 minutes to have to configure for our setup. Yeah, and it's something that we don't really want to spend our time on. Nope, okay, sorry, linked up. It's not really something we want to spend our time on as developers, right? We have product work and feature work to be doing. We have clients and users that we want to be benefiting, and logging isn't usually our main offering to those users. And so unsurprisingly, the main thing I'm not here to talk to you about is logging. I'm here to talk to you about these simple problems that snowball into much larger problems that last for 6 months to a year when they should have been 15 minutes, right? And I'm here to give you a look at such a simple problem that we recently had at CircleCI, which is still ongoing because it will probably never die. And my notes say has dragged out for months, but those are old. It's still going on. So Neil Ford has this wonderful quote which talks about how developers are sucked into complexity. And it's a really important point because it highlights just how eager we typically are to muck up our own problems, how we are to complex whatever problem we have, to get distracted, instead of wanting to actually make our database transactions more resilient. We are much more likely to say, like, well, this person's using tabs. They're using Emacs, and they should be using spaces in Vim, and this is ridiculous. And to get into these inconsequential fights. And so that's what I have come to understand as a bear trap. It's these problems that once you've poked them, they have a tendency to bite, and maybe you get stuck for a little bit longer than you thought. They have a lot of little layers to them, and you know that every single layer is something that you can make objectively better, and you can prove to people that this is better. But by the end of it, you're starting to find that a lot of the friction that you're facing is often your fellow developers. It's not really the problem anymore, but convincing people that, hey, this is actually better. You don't have to do this anymore. I made your life better. And so it's some fun combination of these terms that we're potentially all familiar with, yak shaving, bike shedding, Neil Ford's bug lights. So we're already working on something that's loosely tangentially related to what we already wanted to be doing. Instead of actually working on even maybe that problem, we're debating easy to grasp inconsequential items with our fellow team members, whitespace versus tabs, Emacs versus Vim, although you should just be using cursive. And we're getting distracted by all of these problems, which seem like they'll be much more immediately gratifying. They're going to be lots of praise for getting this right. Everybody on the team is going to love you, and then you get sucked in and you're just lost for days. So about 6 to 8 months ago, CircleCI undertook some feature work called shared environment variables. If you're using CircleCI, you'll know this as contexts, which is not an overloaded term at all. But at Circle, we have a Kubernetes cluster that we deploy to, and to get to the Kubernetes cluster, you go through Helm, and to get to Helm, you have a username and a password. And something that we were finding to be really painful for our ops team, if the password or the username needed to be updated, is they had to go running around trying to find all the places that this username and password combination were being used. Maybe that was in plain text blobs that were existing in our GitHub repos. Maybe that was in encrypted blobs in our GitHub repos. Maybe that was, if you're using Circle, in environment variables in your individual project, which are already opaque and you can't see from the outside. And so we were fighting this problem of, well, we've got a distributed architecture and we have these Clojure libraries, and if anybody wants to update the password, it's going to break half the things across our production environment. And we know that this is something that clients are also going to want. You know, a single choking point for a password so that an ops person can, oh, it did not update up there, sorry. Single choking point for a password such that ops will be able to update this and not have to talk to people. Having to scroll through a massive Slack backlog or search for a particular email in your inbox, or remembering to send that Slack email, whatever, to your distributed team just becomes a nightmare. And we also knew that whatever we ended up building has to be pretty tolerant not only to availability, but as far as security. We have 400,000 plus instances of attack vectors being executed in our system a day. All of your code, all of you are attack vectors to me. That is all you could ever be in our system. And so we need to know what's going on inside of our system, that you're not gaining root access to one of our Nomad hosts, et cetera. And then on top of that, we have many environments and many varied environments. So we not only have our Kubernetes cloud infrastructure, but then we have our local dev environments, and we have our CI. And finally, we've made the leap into hosted on-premise sort of stuff, which is also completely different in its own special way. So all these considerations get wrapped up. And when we decided we were going to start building this functionality, we said, okay, well, we're going to go with maybe the latest, greatest stuff that we can find. Clojure for all of our business logic. We're going to be using Kubernetes to deploy, simple choice. gRPC for all of our inter-service communications to be able to get the secrets between us and to the build agents, whatever. Postgres for a backing store. And then finally, Vault for rotating client secrets and making sure stuff is encrypted. And because we have this one service, we can make sure that, I mean, even generatively speaking, your stuff is secure. It's encrypted at rest. We can't pull anything out and unencrypt it, et cetera, et cetera. So inevitably, when we started ramping up our production instances and sort of demoing this internally, we were going through our logs and making sure everything was great. And I was scrolling through and I was like, oh, great, token, AKIA, secret, token, secret, oh. And realized that all of our secrets that we were putting to this service were getting dumped in plain text to our logs. Luckily, this was just the internal release and was not for our lovely external facing clients, but it didn't matter what it was. Ciphertext, token, key, envar, just a number, it was all being spat to standard out. And so the team we were on said, okay, well, this is just an errant class that we didn't remember to exclude. We need another XML file. We'll go hunt this down, and this will be fine, and we'll release, and stuff's going to be great. But somewhere along the line, people started saying, well, that's great, but what happens in 6 months when we have to onboard somebody? And somebody decides, oh, I'm going to log debug payload, or I'm going to log debug some seemingly fine dynamic var, so I can just see what's going on in my system. And we said, well, in that case, then we would start dumping everything to standard out again. And so we said, well, you know, it would be really nice if we didn't make this such a bad user story for our fellow developers in our service. We're going to put in hazard prevention. So if you try to log something that looks like an AWS token, we'll actually redact it. And so we built just that initially. We said, well, we're not going to be fighting with having to rotate client secrets every time we accidentally log this stuff. We also want to make this a nice user story for not only ourselves in the future when we forget about this stuff, but for others. And so the first example here, you can see we have a simple function, says, is the thing I'm looking at a string? If it is, does it start with AKIA? If it is, redact it. Just put in the redacted message. And the nice thing about what we built is that it just recursively walks any data structure that you're trying to log. And so if you have a map and you want to retain the structure of the map, maybe it's got not just token and secret in it, but it also has some debugging and vars, whatever. The number of users that are in the system at the moment, something like that. If it's a map and it has a secret key, then just reassociate that secret key with your redacted message. And so we end up with something that looks like this second thing here where token and secret are redacted. And we thought ourselves pretty slick. We said, oh, this is really great. You know, we can even do something with known secrets where we override the object to string. So if somebody actually tries to dump this out accidentally, they would never, you know, try to log out danger. Then it'll get redacted that way as well. So we're also preventing proactively this stuff instead of reactively removing it. And so we were really trying to reward people for using our code, reducing the barrier to entry into this and making development time in the future much faster. Sort of that idea of accretion versus deletion, of making this a much simpler thing to have to deal with and not having to deal with this external stuff. But of course, after about 2 weeks of working on this, we get ready to go back to production, and everything is still spitting in standard out in plain text. And somehow there was a difference in our Docker containers, something along those lines. But we realized at that point, you know, how have we missed all of these various little things? And it was because apparently our very simple service had 7 or more loggers or logging frameworks kicking around under the hood. You may not realize this, but this is probably going on in your Clojure application too. One of the greatest strengths to Clojure is that it sits on top of the JVM. And the JVM, everybody has re-implemented their own logging system. So you've got slif4j, which we've all probably used, XML, etc. You've got log4j, you've got commons logging, Java util logging, and apparently Netty. Netty was the one that was logging on its own via nothing else that was being used, and we had no idea that it was a problem, and didn't show up in our testing or anything like that, which was really lovely. There's also logback, which we are now using, so we've introduced yet another bit of complexion into this, but Clojure is also not innocent in this. We decided to go with Timber to solve all of our problems, but Clojure tools logging also exists and was also in our Clojure, in our code base. So we had a choice at this point of, do we continue trying to include all of the XML files that we might need, all the envars that we need, or is there a way to maybe simplify our problem? And we realized, well, everything that's in the JVM probably can pipe over to slif4j. So let's try and focus on getting everything that's in the JVM to slif4j, doing whatever plumbing we need to, and then piping everything in slif4j over to Timber. And then all of our hazard prevention stuff will just work naturally in the future. And if we have some other logger at some point that comes along, which we inevitably will, we can just pipe that through Timber as well. And this is apparently the bit of magic that I have been looking for since I started in Clojure. You have to include all 4 of those jars in your class path. Tools logging pipes to slif4j automatically under the hood. But then things like Java Commons logging and log4j, you just have to include those jars and they will automatically pipe over. Slif4j will automatically pipe over to Timber. But util logging and Netty, you actually have to run those Java commands, which was the real fun gotcha. So at this point, we were looking to balance our implementation as being something very simple, but also being a significant amount of work for others. So another approach to this would have been just to dump XML files everywhere else, which doesn't really ease the pain for somebody else. If they forget one of those, it's still painful. If we put this into a project, CLJ, maybe all somebody has to run now is this init, and it gets them what they need. So trying to balance a simple solution with something that is significant and meaningful. So after about 12 weeks of working on this, along with other feature development, we started shopping this around to other teams. We had this baked into a microservice framework at the time, which allowed us to iterate really quickly. Frameworks are a very evil word in the Clojure community, if you don't already know. A lot of people have a very knee-jerk reaction to that. And so our beta testers were really, really happy with this. They were just really happy that various little things just ended up getting fixed. But one of the things we started realizing is that the more and more people are using this, the less information is actually available. And CircleCI, we generate about 300 million lines of logs a day. It's about 1.5 terabytes. It's a lot of GitHub JSON just dumped right to the logs, which also has problems. But using this data becomes kind of an issue. 1.5 terabytes of data is not a small amount to have to just simply walk over. And so for people like our security team who are trying to audit clients, our ops team trying to track down Bitcoin miners, or just our developers doing monitoring and observability, they need to be able to move through this data quite quickly. And when you start talking about the size and then the distribution of the team, trying to remind people, oh, hey, you didn't set up your logging sidecar correctly. You don't have your Logstash grokker working correctly. It's not parsing any of these special fields. So we wanted to start saying, okay, well, we don't have to configure any of the loggers anymore. That's already all being handled. But we don't want to have people fighting with XML or fighting with this new Docker container or a Logstash grok, whatever. We want to make this really simple, and we also want to give you the benefit of having even more detail on every log line to make this really, really easy for ops or security, whatever. So we're including things like the project that you're actually spitting out, the version, maybe what time the service came up at. Maybe the problem you're looking at is only for services that have been up for more than a day, which indicates probably a memory leak. The K8s pod, K8s namespace. So all this stuff that is more feature benefit for whoever's using this. People don't have to think about this. It makes debugging really, really magical and easy when you just open up the command line and boom, everything is right there for you. And to make this even easier, we decided we were going to be quite opinionated and spit everything as JSON to Logstash. So every specialized field that now gets included is also now indexed automatically in Logstash. This isn't something that gets grokked out. It's not something that one of our developers in Japan, who was asleep during the all hands, when we mentioned this one thing offhand in a 30-second quip, didn't pick up on and didn't do, and now we're saying, okay, all these logs are absolutely meaningless, we're just going to delete them all. And so we started shopping this around, and about week 15, we said, okay, we want to be sharing this with the greater dev environment. Let's try and make sure that everything is nicely tested, and so that anybody who is across any of these time zones can't remove one of these things accidentally. And that's sort of a really key point to all of this, is that trying to coordinate a distributed team is really, really difficult. Slack messages don't work, emails don't work. You can try and threaten people for not doing things right. You can simply say, oh, well, we need better dev paradigms. People just need to be smarter. But it's really just blowing people off instead of saying, oh, I could have written a simple test that actually makes sure that you didn't remove this and given you a heads up. I could have been nicer is a lot harder to end up saying than, oh, maybe you're just less intelligent than I am. And so with Timber, nicely, testing is really simple. You just write a different appender, put everything into an atom, and then read everything out of that, or however more functionally you want to do that. But yeah, distributed coordination is really non-trivial. Write tests. Unsurprisingly, from a CI company, I care about tests. So many yaks shaved later, we found ourselves ready to start sharing our work with the entire dev team. Much like moths to a flame or bears in a trap, we were unknowingly heading right to disaster. So it's about week 16 now, about 4 months into this. We've been doing other things than just logging. Context has already gone out and been somewhat of a success, whatever. And the release happens. We say, hey, everybody, you don't have to fight with logging anymore. You should totally put us on a pedestal and love us for eternity. Oh, that's the wrong button. And there was immediately a lot of questions. People were sort of asking, well, why are we using Timber? I want to use Logback. I want to use Slip4j. This is ridiculous. Why am I using Timber? Why is this baked into a microservice framework? Don't you know that frameworks are the devil's work? Are you the devil? We really don't care. Alex, context team, it's okay. We're just going to go build our own thing. Don't worry about it. We got this. We wanted maybe Spider-Man 2 reviews, and at best we got like Spider-Man 3, or worse, maybe the reboot. It was a little bit hard. And we sort of realized, oh, we probably should have gotten conflicting peer feedback much earlier. So the people who were using the framework early on had already bought into this idea that there's a bunch of stuff I don't want to fight with, and they were fine continuing to use this framework. But telling people, oh, you need to just use this microservice framework to fix your logging problem was a little bit of a tough sell. And it's a little bit ridiculous when you think about it like that. So we had not really balanced this idea of getting feedback in our ideation lifecycle early. So 6 months in, CircleCI has now spun up a Backplane team. So we have a team that is solely concerned with cross-cutting problems. They are there to make these cross-cutting decisions and say, no, we are the authority on this. We have the authority to make a singular decision on these things. They are splitting up that dirty word of microservice framework into microservice chassis. So much smaller, easy to use things that can be linked together or clipped together very simply. And so if you want to do logging, all you do is pull in the logging chassis and things just work. And it's been a much easier sell. And what we've seen is that we've been able to start balancing our developer cycle time with our adoption cycle time. And that wasn't something we were really considering before, is that it might have been really, really easy for us as developers to continue iterating on fixing all these problems in this framework, but getting other people to buy into it was just too tough of an ask. And so trying to get people to start using it, I mean, 6 months went by, 3 months went by, and nobody was really picking up on this. Others were just saying, oh, we saw what you did, we put it in our code base, and it's fine. So in conclusion, the things that we have found, and I think we are going to carry forward with our solutions in the future when we start running into these bear trap sort of things, is trying to find differing views of opinions early, not just relying on the people who are bought into stuff immediately. Trying to go to the person who we know is going to be the PR curmudgeon and say, hey, Bob, we know that you're the PR curmudgeon. What do you not like about this solution? Really early on, and trying to get people bought in and trying to flesh out differing opinions. We always want to try and reward people for using our code, so carrot over stick. We don't want to break people or make their stuff much harder. And that comes a lot with, or that's integrated very thoroughly with trying to simplify your problem while still solving something meaningful. So making your work easier is going to make it easier for others to use your work. If you don't need that map key, don't punish people for not having it present, even though it was needed before. Just don't look for it, whatever the case might be, spec, etc. Coordination with a distributed team is really non-trivial, so try to automate this at every step you can. And then lastly, balancing your development cycle time with your adoption cycle time and thinking how that is going to play out in the long term. So it was really easy for us to put everything into one repo and one library, but it was really, really tough for people to buy into that I need to bring in a version of Postgres to also get my logging. Really difficult to say, like, hey, you need to worry about rollbar and statsd and all this other stuff in order to get logging working in your application. In closing, everything is available up at Unclogging at my personal GitHub. And this will all be coming out as a blog post on CircleCI's blog here next week or the week after. I want to say thank you to the clojureD team for having me here to Berlin. It's a great city, wonderful city. Can't wait to come back. And then thank you to Natalie, Jillian, Danny, Nate, and I definitely can't read the last one on there, but I will take the time to do it. Gordon. All of you have been wonderful and a huge help for getting me to this point, and also for editing all of my terrible grammar for the blog post, since I write at probably a 3rd grade level. So yeah, thank you all for listening, and that's pretty much it. Thanks, everybody.
Thank you. I think we have time for 2 questions.
Very interesting and concrete, thank you. That Backplane team you formed,
yes.
Doesn't that become a bottleneck?
It depends on the things that they are working on. So something that is necessary in order to be able to solicit peer feedback is actually having a MVP, if you will, an initial solution that you can start shopping around to people. So teams are still encouraged that if you're running upon a new problem, to go solve it and think through it, and then give it to the Backplane team so that they can say, well, this is actually something that everybody else is doing. Try and use this different library. So for certain things, it has been a bottleneck, but again, we're running so many instances of foreign code a day that security vulnerabilities become sort of an issue. So maybe you're using a Docker container that you hadn't realized is out of date, or a Java library that's out of date and needs to be updated. That's something that this team is going to be concerned with. So whether they are coordinating discussion and facilitating discussion for this stuff, or actually handling building it, we've seen that it's been quite useful so far for a team of our size to have these people who are dealing with just cross-cutting concerns.
One more question?
Thanks for sharing. By the way, how do you plan on solving this? So there's a peer feedback often problem. Do you think of RFCs or MVP, like you said, but something even before the MVP, like you start thinking about the problem, how would you put that problem out to people so they can review it in a company?
Yeah, so what I personally have started to do, I mean, like I said, this is still ongoing, and this is going to be ongoing forever. But what we have started to do at Circle is encourage doing that MVP work to sort of iterate on a simple solution sort of early, and then to do something called charrettes. This is a French word which has a really cool history. You should look into that. What we have been using it for is sort of design discussions, saying, hey, our team has run into this. Who else is concerned about this? Who else is concerned about how we are doing error parsing or error in transmission via gRPC, whatever. What are we going to use for database transactions? Are we going to use JavaScript transactions, or are we going to encourage people to just throw errors from the database, whatever. And so those conversations have been really helpful to hold panels early and write down all the differing opinions so that later when we have to come back to it, we remember what we were talking about before. So that's been good for soliciting peer feedback that's conflicting early.
Well, we're out of time. Thank you so much.